Okay, Danny, just because you have a counter doesn't mean you don't. Like Danny takes photographs sometimes, so he actually does not have it on there. Other folks could come up with groups.
Left one.
All right, I will, in the interest of just keeping things moving, kind of talk while some folks don't.
No, there's video.
So this is amazing. This is serendipitous. I don't have any prior association with FIRST or FRC.
Super brilliant.
Who is he?
This machine learning guy that we hired. The older guy. Yeah, he's actually a super nice guy too.
So are we actually? First of all, are we streaming? All right. Great.
Why are they showing the audience?
Because that's the camera from our.
Yeah. Justin Fjellner, can you mute? Got it. So I am a former organizer of the deep learning RTP meetup. Organized that pretty actively for a couple of years. Hung up my hat late December, and then Andrew Schreiber, who is also a member of that meetup, reached out to me about this. And when I heard about the nature of this potential meetup, I came out of retirement because it was so awesome. This rocky few years, I was like, oh wow, you've had me sponsored by NVIDIA. But then the concept was so great, right? A high school robotics. And so graciously, Lifeomic agreed. I actually didn't even know that. I've been working for about 3 months. I didn't even know that Lifeomic has actually a list of Code and Conf is another one, Triangle, Dev, DevOps, right? So speaking of that, our director is Chris. So anybody with questions about Lifeomic, I'll say a little bit more about Lifeomic, but he is the man. Yeah, speaking of AV and such, people often want wireless access. So sorry, the sign is so small, but we do have it. You can see the network and the password on that sign and that sign. So yeah, so you know, we connected and said, yeah, this is great. Let's do this under the umbrella of the deep learning meetup. And this is record setting. Like I said, in order to feel like for a while. I mean, we've come close to this before, but I think this is probably a record both in terms of RTP and bodies. So let's just say a little bit about Lifeomic. This is a lot of firsts. Many first-time members here of the DLRTP. By the way, the founder of the DLRTP is and spiritual leader. No, Danny, don't. So anybody who is interested, maybe here for the first time here because of the robotics group is actually kind of interested in deep learning and wants to get into a group that'll help you grow your skills. The DLRTP does that, and Danny is the man. Okay, so about Lifeomic, it's the first time a DLRTP has been hosted here. Lifeomic is a software technology fundamentally a precision health company that is firmly forward-looking into sort of the digital cloud, machine learning, and that sort of three major products. One is security-based, that's called Jupyter One, and that we know that much about it, I think here 2 months, but it's your data needs to be secure. Another one is sorry. Very good. Anybody who's ever looked like OAuth authentication protocol knows what an incredibly complicated sort of thing this is in Jupyter One. Another one is a precision health cloud offering, a cloud storage offering that's sort of built for medical data, among other things, and that's called Precision Health Cloud. And that's really gaining some traction. A lot of people are starting to use that. And the third kind of product and sort of pillar of what Lifeomic does are the suite of apps. And it's just one app right now, but it's a great app. It's called Life, and it's for internet passing. All the time. It's cool, and it's part of the growing set of health-related apps to, So yeah, anybody interested? I don't think there are any listed machine learning roles, but we are hiring in all kinds of software positions all kinds of web design, right? And so anybody who's interested in that kind of position, should check out the careers page at lifecomic.com. We have a lot of. Okay, so that's. I just got a Slack message from somebody saying, hey, so what's our internship course? I think interested potential interns could reach out as well. Right. All right, so that's pretty much what I have to say with the intro of the RTP and Lifecomic. I'm here. I do machine learning here. I'm doing some amazing projects. So that's kind of the machine learning thing. Lifecomic is definitely in deep and very much about using ML where possible, and there's obviously so many ways that we can help technology. But now, what we always do is just a quick round of announcements before I hand it over to Marshall Massengill, who's going to be MC for the first computer corner side. So whoever is hiring, if you have hiring an ML position, if you know of an ML related event, if you'd like to just make known public, or if you are a job seeker and you just like to sort of say, hi, I'm looking for an ML position. In any of those three categories, please use your hand up and say what you got. All right, go for it.
Well, we'll talk about the School of Science and Math. I am the acting director for the Artificial Intelligence Curriculum Development Project that I'll mention more in detail briefly. We are looking for someone at the intersection of education and machine learning to help develop a K-12 curriculum that will incorporate AI and machine learning. Students throughout North Carolina. I like the job.
No, that's fantastic. Your name is
Joe Labulia.
Joe Labulia. Okay, yeah, sorry. Okay, great. Who do you want?
Chris, I work for iRobot, and for we're hiring AI and machine learning computer vision involved. Can't do it long. You didn't get like 12 inches freaking yourself. Machine learning is involved. You need to work in the market for this. It's truth, man. It's truth in market. It's great.
Our job is here.
Okay. Yeah. Awesome. Okay. Great. Well, my great pleasure to hand it over to Marshall Massengill. Thank you so much.
Thank you. So, I want to say thank you to these guys for having us. I had a heck of a time trying to find a place to post this thing. So, and I reached out. Andrew was the one who made the contact originally with the compliant group and put me in touch. I'm glad you guys were able to host this. And not only host this, but do it for free, because NVIDIA was like, begging, we were trying to find somewhere. We could not pay people money. They would not take money to host the events. So, I don't know. Anyway, I'm glad to be here. It's awesome. We're going to talk about Jetson stuff. Before I do that, though, I want to introduce myself. So, I'm Marshall Massengill. I graduated this awesome school called the North Carolina School of Science and Math in 2005, so forever ago. I don't even know if you guys were barely alive at that point. So, graduated the school in 2005, went on to work for IBM, and bounced around with a bunch of different companies. Found myself finally in a senior consulting role at VMware, which is right now doing cloud management, DevOps related stuff. It's awesome. Love my job. So the reason I bring up NCSSM is because of Joe, who's over here, who actually just introduced himself a minute ago, and something that happened recently with one of our other alumni called Ryden, CEO for a company called Precision Lender, based out of Gary. Precision Lender is also getting into the machine learning business and is looking to hire more people tomorrow. So check them out by all means. The reason I bring that up, though, is because the world is changing rapidly, and I think we're all getting into this place where we're trying to make computers learn how to do the things that we all think we're going to into, like recognize falls, cars, So, and I think it's kind of important piece of generation. Holding on to technology, kind of secret. So I will let Joe take it from there.
Yeah. A few minutes. So the North Carolina School of Science and Mathematics is a residential public high school. 11th and 12th graders are actually part of the UNC system school. So we have a lot of latitude in the curriculum that we run. One of our alumni, as Marshall said, donated $2 million to start a program in innovation and leadership in AI for high school students and younger K-12 education. The idea being that AI, data science is so transformative in our society, both as a technology and both how we act and interact with technology as citizens, that this has to be part of everyone's education. Just for good citizenship, good leadership, and to find that pipeline of people interested in the things that are coming online. So we announced the gift just last month, and we're currently hiring our first employee, and he or she and I will work together to flesh out this program. So it's really on the ground floor on how we integrate these concepts to people of all ages. One key part of this curriculum is that it will be an open source curriculum. So if you just want to contribute as part of a community, you have a cool example you think you share well with students, that's something you can help develop, contribute to our open source curriculum, and that will be shared worldwide with any educators or students who want to be involved with AI. The robotics team has been instrumental in securing this gift because they demonstrated to the donor, they demonstrated to me and to the school that high school students get this, do this, not only in the engineering and computer science department, or high school with an engineering and science department, but also in the sciences, math, and even in the humanities. High school students can do AI, they can do machine learning, they're eager for it. And so we are here to deliver that to them where they want it to be. So technical, technology, ethical, societal issues, how we study AI, how it transforms society. So,
yeah, Joe's been awesome as our faculty advisor for the team, and I can safely say that your things we're doing and wouldn't be where we are for the team and kind of getting this all right, with that, I'm going to move on to the actual presentation. No, not yet. Let me go through. I'll do this presentation real quick, which was shamelessly stolen from NVIDIA directly. I do not work for NVIDIA. This is technically one of their marketing presentations, and I'm technically trying to sell you these things. I'll be honest with you. I'm not super interested in trying to sell them to you directly for the purpose of selling you something. I'm more interested in the fact that it's really cool thing, and it does really cool things. That to me is the interesting part. So that's what I'm going to be talking about more so than anything else. I also don't work for NVIDIA. Kevin over here, who is the co-mentor on this team, also an NCS alumni, and graduated when wrote dinosaurs. That's stuff on our resume. Yeah, exactly. So, but Kevin does work for NVIDIA, and if you have specific questions about their our program, about the Jetson and things like that, we're going to do our best to do it. When I'm done with all of this, these guys are going to get up and talk to you about how we actually do things regularly. So with that in mind, this is the Jetson meetup stuff. What's really cool is they've done these events like everywhere. This is the first one that's like ever been done by somebody that's not NVIDIA. So it's the first one ever hosted by anybody other than them. So they're actually watching on the live stream like many people were. They will be and watching how I do. So I hope they're enjoying this. I hope I'm doing okay. Yeah, no pressure. So the Jetson Xavier, the AGX Xavier platform, which is this little tiny box that's sitting here, which is actually the development kit. In fact, the platform itself is actually a lot smaller than that. It's a little tiny module that's about yay big that sits there. So that's less than a 5-inch cube, and it's going to do some awesome stuff in a little while when we get to it. Things that are driving all this, NVIDIA has realized that they started selling to graphics units. They realized though that it turns out if you take them and turn them sideways, do some funny programming for them. So basically things that just process raw data, and they're very good at it, and they're very, very quick at it. So they keep adapting their GPU technology over time to more and more platforms, different systems, and the ultimate goal here is to.
Oh, you're good. No. I'm getting the mic set up for you.
Oh, okay.
Sorry.
Why not, Mike? I need to be.
No.
That works better. That would probably make it so people online can hear me. Sorry. So, cool. So yeah, one of the things, if you ever have the opportunity to go to like GTC, their technology conference or something, NVIDIA really likes to talk about the fact that GPUs have massively outperformed CPU technology in terms of performance, and it continues to. So they're on a completely different scale than Moore's Law, according to them. Whether that's true or not, it's a whole other thing, but whatever. We're going to go with it and say that they are. It allows us to do awesome stuff, again. So it's cool because we've now taught computers to write code, where basically this whole notion of machine learning is teaching computers how to do things. So we're not just writing code to do something outright. We're telling the computer, you go learn how to do it and figure it out on your own, which is oddly enough what we do for mentoring too. So anyway, yeah, so we're on that path. We're also ending up with autonomous robots, which is really cool. That's where a lot of what we do is kind of headed very slowly. It's taking time to get there. It's not like we're, going to go out and have an autonomous robot and run an FRC field tomorrow, but I think within the next 2 to 3 years, it's something that somebody's going to pull off, which is really cool. So we'll get into that a little more later. So continuing on. The Jetson, which is this platform that NVIDIA introduced back in like 2014, we've been using them since then. They started off with this thing called the TX1, or TK1 rather. The TK1 was a little board about yay big. I forget, it didn't have an actual form factor. It's just like a 6-inch square board, give or take. 32-bit ARM CPU, bolted right beside it on a PCIe bus was a GPU of some variety that was, I don't know, like 920-ish. It was somewhere in the like GTX 920 range, 910, something like that. So it didn't have a whole lot of power, but it had enough to allow us to recognize recycling bins. And if I have time later, we'll pull up some YouTube videos and go through some stuff. But we were recognizing an arbitrary game piece using something called a cascade classifier to do so. That was written by one of our students back in 2015. So right after we got the board in 2014. It's the first time we were ever able to successfully integrate what we call a co-processor on one of our robots. We have a main processor from National Instruments that we have to use, which is really cool. A couple years later, they introduced the TX1. The TX1 was different in that it was a 64-bit ARM CPU, and bolted beside it was a much faster GPU. And then a year later, they came out with the TX2, which we had to have immediately because, quite frankly, it was even better. So they doubled the number of cores on the CPU side, and I forget what they did on the GPU side, but it got even faster and even crazier. And now that brings us to today, which, and in fact, like 6 months ago, I think, give or take, less than that. Yeah, roughly. We got some early access because we're part of the development program, but the Xavier platform is not that old. In fact, it just came out that long ago. And in a little while, when I run the demo, which some of you might have caught earlier briefly when I had it running to prove it would work, making sure that the sacrifice to the demo gods was all good. The demo is a set of 25 1080p streams all running simultaneously to do recognition for vehicles and people. So I will show that. That is coming out of a less than 5-inch cube. So just keep that in mind. So yeah, NVIDIA's increased the number of partners that they have. So the TX1, TX2 are actually these little boards that are about, I don't know, yay big. They're, in fact, that big. So the board itself that this is bolted to, which is like a mini ITX board, anyway, the board itself is actually just a carrier. You can bolt them to other carriers. In fact, we do regularly. They get a lot smaller than this, which is awesome. In fact, the smallest carriers come from a company called Connect Tech. So, and hopefully they're watching too, or will be watching at some point. They're like, oh yeah, we should give those guys some more of those. But the smallest ones come from a company called Connect Tech. They break out all of the I/O for these boards. So, and it's stuff like NVMe, USB 3.0, USB 2.0, serial, and some other stuff. HDMI, Ethernet, yeah. There's a wireless way. There's a way to do wireless on them, which is kind of nice. Though not so much for the Xavier, I believe. I think they changed that. So, like I said, there's tons of autonomous machines. We've learned about Lithomic earlier doing machine learning. Well, it's coming to like every industry. And I can tell you, because I work for VMware, we watch a lot of this stuff too, because we help all of these companies do what they do with our products. So we're watching this space as well, trying to figure out how we can apply our products to it, which is really cool. In fact, at VMworld this past summer, they announced something. So if anybody's heard of ESXi, which is our big hypervisor that we sell and sometimes give away, VMware ported ESXi to run on ARM. And in fact, I've been pestering the living crap out of the group that did the port to get them to port it to this thing. So if you, like me, want to run virtualized environments on an ARM platform with a GPU bolted to it, please pester your local VMware rep and tell them you want this. So hopefully it happens. So the Xavier, there's the module itself. You can actually play with the performance settings. And in fact, you have to play with the performance settings to run some of the more advanced stuff. So that 1080p thing that I'm going to show you with 25 streams, it does chew up 30 watts of power. However, it's really cool because it's all coming off of USB-C with a little converter down there, so you can run it off of your MacBook adapter, which is kind of neat. 512 CUDA tensor cores, so this is the new tensor core that NVIDIA has started shipping on all the GPUs. And finally, we have kind of a unification between the desktop GPUs and the mobile GPUs in terms of what that CUDA core actually is. So all CUDA cores are now equal. They were not previously, which is kind of cool. It's an 8-core ARM CPU, and again, playing with the performance settings actually changes the core count for the CPU, I believe. So it goes up and down.
Memory speeds.
Memory speeds too, yeah, there's a couple other things. So that price might or might not be accurate, and I'll get to that when we get to the end of this deck, and I'll explain things. So that price for the FRC team, people in the room, that doesn't work, right? So, and that's because we have a maximum part cost limit of now $500. I don't know if that'll change. I don't know if NVIDIA is going to eventually donate a bunch of these to something and allow us to use them, but maybe, hopefully. I will push for it in every way that I can because I really want to put one of these on a robot because that's cool. So yeah, tons of power, which is awesome, and it's tiny. Again, little hardware shot of the CPU. Again, I'm not in marketing, and I don't work for NVIDIA, so I can tell you that it has 16 lanes of CSI, which really means that you can plug 16 different cameras into it simultaneously, which is kind of cool. There's some other stuff too. I will mention briefly that you can run NVMe on it, and in fact, on these little dev boards underneath everything, if you pull off the screws and pull the thing off the board, there's an NVMe slot that you can put NVMe memory into, which is kind of cool. So I forget how much RAM is on this thing. It's up here somewhere, I'm sure, but I'm not seeing it at the moment. USB 3.1, which is awesome because we can go crazy fast with I/O at that point. We can hook up things like a stereoscopic camera from, say, Stereo Labs, which makes the Z, which is awesome. There's some new stuff from Intel that's coming out with the RealSense system that might be viable as well. So having that makes it nice. Also Ethernet, which is awesome because that's what we need on our robots, at least, to communicate. So performance. That's a Core i7 1070. That's the Jetson Xavier. I fully believe this because I can tell you that my system at home, which does not have a 1070 but has some 1080is, can't keep up with this thing in terms of what it's doing processing-wise. So, Jetpack. So this is the software world for the Jetsons. NVIDIA uses this thing called Jetpack. Noticing the theme. So Jetpack is their software deployment system. You have to have a Ubuntu host OS, which I think was 1604, but now might be able to run on 1804. So, but you install it and then basically connect up your Jetson to your dev board of any variety, and magically it dumps all the stuff over that you need to flash the image onto it, including all of the OpenCV libraries. There's some special libraries from NVIDIA, all the binary blob stuff that they do with the kernel, everything that you need to actually make this thing work. It all comes from that, including the CUDA libraries and other stuff. Works really well, so. And they keep advancing it, which is kind of cool. So these are companies that have actually adopted the Xavier. I'm guessing this is all like crazy early adopters. So Fanuc, Go Figure, Denso, Yamaha. These are the ones I recognize anyway. So the ecosystem for software and support, there's a ton of stuff. I can tell you that MATLAB works with the Xavier platform because it worked with all the other Jetson platforms, and it's really cool because you can kind of write very basic stuff in MATLAB and then port the code over and it just goes, which is neat. We actually talked to them when we were at ROSCON specifically, which is kind of cool. There's a bunch of companies that do design work for these things. There are a ton of carrier boards out there that are actually designed to mount this and provide different breakouts. Some of them actually provide multiple places to plug in Jetsons, so you can get like 4 of them on a single board all talking to one another. So they do act as different root complexes, unfortunately, but that's okay. They do also make the drive system, which has a single root complex is it 2 separate systems? I can't remember. Depends on the system. So yeah, fair enough. So
TensorFlow or Converge.
yep, all of that's there. In fact, out of the box with Jetpack, you get most of those installed by default, which is awesome. So you can just run that stuff on here. I don't know whether it's installed on this one, but we can pull it up and play with it. So Jetson family, the Xavier is the brand new one. There's the TX2. They have a 4 gig version now, so 4 gigs of memory instead of 8. I think we're going to stick with the 8. So
Yeah, I mean,
maybe.
if you have an application that fits in 4 gig, you can probably save some money on master.
They've also recently added this industrial model. The industrial model drops the entire heatsink off of this and the fan for a fully enclosed system, which is kind of cool. So you can actually like get companies that will embed them on their boards and then epoxy the whole thing for you. So it's just basically a solid state system. So Jetpack and then the DeepStream SDKs, that's all their development software stuff. The NVIDIA embedded developer group, which they have online, basically you go sign up for an account, it's free. Once you're in, you can post on their forums, ask questions, that kind of thing. They fully support all this stuff. And I can tell you for a fact, if you have a question and you post it on the forums, you will get a response at 2 in the morning from a guy named Dustin Franklin. Dusty is awesome. He's the guy we've been in contact with anytime we have a technical problem, and he's the one who actually established that demo and sent it to me. So Dusty's just an all-around awesome guy and seems to keep odd hours. So
I do have access to our internal
yeah.
forums, get updated when people post in there, so they do keep an eye on the forums that are externally facing, and they are serious about support.
Yeah, it's really cool to actually have that level of support from any organization. So yeah, so if you have questions, that's a good place to go and ask them. So they do fully support their community. AI resources, this is cool. They've started doing this deep learning institute thing and setting up all of their platforms for like software development, so you can actually get running a lot faster. So you're asking about TensorFlow. It's one of the things that NVIDIA is actually throwing resources at and trying to like expand and get better at is how do you go from having a thing in front of you to making it do something useful. So they're trying to get people off the ground with the stuff faster and better, which also plays in nicely with what Science and Math is trying to do with the AI program. So how do we enable students? How do we do it quickly? So they've also partnered with, I can't remember the name of the company, but they were actually giving us free resources last year for online learning for this. I don't remember the name of them, but there's a company that they have partnered with that basically allows you to spin up a GPU instance in a cloud somewhere and instantly run stuff from there, which is kind of cool. So if you go online, you can sign up for an account and play. So Xavier meetup partners, the Zebracorns are not on here, but we'll fix that. So I don't know where, I guess we go here probably. So the Jetson family, I mentioned the TX1 and the TX2. The TK1 is actually like end of life, I think, or I don't know. They're not supporting it really. I think maybe for some commercial customers, but kind of done at this point. The TX2, different flavors. The industrial one's actually really interesting to me personally, but the 8 GB one is the one you get with the dev kit. And then the Xavier dev kit, which is freaking tiny. I don't know. I'm still amazed at how tiny this thing is. So there we go. So here's the trick. That's the magic meetup special price that they have told me I can advertise. I will tell you, if you go here and sign up fill out the survey, it's just asking for a name and email address. we can hook you up with NVIDIA. They'll be in touch about giving you guys a discount on these. So don't pay full price. I don't know. So yes, it's expensive. It's a freaking computer. It's a laptop in a 5-inch cube. So like, I don't know. All right. So I don't work in marketing. I've already said this. So, all right. If we can switch this to HDMI 4. So, I have no idea how to do that. In fact, I will leave.
You can leave that up over there.
Yeah, I will leave that up there. If you guys, or not, you know, that would be easy. Let's try that. All right, cool. Sweet. So I'm gonna run this demo, and it should work pretty well, I hope. So, and the super secret password for root is NVIDIA. So it's better than Ubuntu. And then what you're going to see is 25 1080p streams all running simultaneously, all tracking cars and people. And if I go and do this right, click on one, you can see that. And if I click on another one, you can see that. And if I click on another one, you can see that. I'll do one at the airport here. So, and yes, these are recorded streams, but it will do this live as well, which is crazy impressive to me. To have that much I/O on a system and processing capability.
Speaking from experience, it's actually harder to do it from video just because you're streaming that much from disk.
Yes.
It's actually a little bit easier.
Yeah.
So it's reading the stream live, right? The interpretation is all happening.
Yes, the interpretation is happening live. So, and I forget the nets that they're using, but they are all like open source things. So
yeah, NVIDIA does have a GitHub page which has a bunch of models that are ported to run on Jetson, and they've got the TensorRT stuff that Marshall didn't talk about, which is kind of an interpretation library that'll read in models from various formats, cafe, those kind of things, and turn them into something that's optimized to run on the Jetson architecture. So I'm sure that's how it's partially how it's doing this.
I'm blown away. I mean, again, this is something that from my perspective, like you could not have done 5 years ago on something 8 times the size, and yet here we are doing it on something that's less than a 5-inch key. So if anybody doesn't believe that technology is changing rapidly, there's your proof. Yeah, so that's the demo. I don't really have anything else to say about it. It's probably going to get kind of warm at some point running this thing, but whatever. You throw it in a box with a fan, it's fine.
Is it blurring on the faces, or are the faces blurred on the input?
They are probably blurred on the input if I had to guess. So, yeah. So, I don't really know what's going on. So, yeah, it's crazy to me.
Models have to be quantified.
You know,
Or were you able to take your OLV tree, which I guess this is, and
Yeah.
run it kind of almost off the shelf.
I'm not exactly sure of the model, but they do run off the shelf with a lot of like ResNet and that kind of stuff. They pull models in. I'm pretty sure they're using the same training data, but I think they may be trying to optimize the model itself. They're optimizing it.
Right, so you can make a research product out of taking one of these models and boiling it down from 50 megabytes to 5 megabytes.
Yeah.
Did they have to do that? Or are these working just in their sort of original state?
I would have to go ask someone specifically. I don't know at the moment. As far as I know, it's a standard net setup. In fact, I'm going to do a thing where I'm going to check an email and see if I can tell you the answer to that, because I think they sent me more information.
Be sure this demo is actually online, not the demo with the 25 streams, but a single stream online. So probably want to do that, and you should be able to answer.
But sure, yeah, thanks, yeah.
I'm looking to see.
What kind of database is it?
So the thing I have from Dusty says the demo is running ResNet-based multi-class object detection of vehicles and pedestrians on 25 full HD 1080p 30 streams simultaneously. It is processing every stream at full resolution and full frame rate, even though they are visualized smaller to fit them all on one screen, And when you maximize the stream, it is still processing all the other streams in the background. So, and then he has some quick math. 1020 times 1080 times 30 times 25 equals 1,555 megapixels per second. It is accelerated using Deep Stream 3.0, Tensor RT, and Jetpack 4.11. There.
You were saying.
So,
Kind of this drawing, I recognize it.
Yeah. Honestly, I'm not sure. I'm pretty sure he said what resonant,
ResNet.
which I think just gives bounding boxing classes.
Yeah, that's what I think too.
I don't know if it's. I know we have models that will do things like orientation and objects also. But I'm not that sure.
There are, in fact, when I was at GTC a couple years ago, one of the things I had running was a group from Dassault Systems was running a Lego sensing system for one of the like FANUC arms. So they were literally trying to rotate Lego pieces in place. But the reason they were able to do it was based on using the like recognition that this is the red 2x2 square thing, and I'm going to have to flip it this many degrees to place it in a different spot. So.
Most recognition, there is no money there. This is computer vision, right? I mean, this is a miracle for the last 5 years, now times 25 on this device. It's getting a raw image that's just seen.
Now, when you've got binocular history,
You can get depth.
But it doesn't need that.
No. I can keep answering questions if you guys have them. I would like to give the students the opportunity to do whatever setup you guys need to do. You just want to pull it up on my laptop. So hopefully my laptop doesn't die. Something out there. Oh, we're fine. We've got it.
What an unsure.
Answer your question about stereoscopic cameras. There's also models that
If you want to, click the stop sharing button. So down there. So
obviously the more
down a little bit. Yeah, or that. Why? Is it working?
Machine learning is always hard to
I'll check later. Give me good news later.
I guess taking a tool like this.
So while they're setting up, I will briefly. I'm gonna do a couple things. I want to brag about these guys. So Niall and Olivia actually went with myself, Kevin, and one other mentor, Megan, to Madrid in the fall, and we went to Madrid, which is insane to me that I took high school students to a foreign country, but it did. We took these students over there to present at something called ROSCON. ROS is ROS, the robot operating system. It's not really an operating system. I didn't name it. Don't complain to me about it. It's really a framework for how to design robots and software. And these guys are going to talk more about it and why it's so crazy important and why we got into this. But it was just an awesome experience all around. Mason has been doing this as well this past year, so we'll leave it running. Let's see if it keeps running. We'll see how warm it gets. But Mason's been doing some of this as well. Mason's actually had some experience both at the MIT Beaverworks program doing ROS research, I believe, with like an online class. Correct?
Slightly, yeah.
Yep. So he'll talk about that a little bit, and then also with some work with strapping the Jetson to a flying platform rather than one with wheels. So, and then we also had some students a couple years ago strap one to a rocket. I don't know if we actually got that one back. I don't know where it ended up.
I didn't have the heart to ask.
Yeah, yeah, I didn't either. So I do know that out of that though came some open source work where one of the students contributed a set of libraries to the ROS family for it was like an IMU system, so it was kind of cool. So, and she's now interning with Toyota, I believe. I hope Toshiba, Toyota. I don't remember. So I know I wrote a rec letter because they called me up and asked me for references for her, which is crazy cool. So anyway, I will let these guys take it away.
Hi. So I'm Olivia Fujikawa.
And I'm Niall Blaine.
So as Emotional kind of introduced us, we're both students on the NCS 10 robotics team as you before. So we run NVIDIA Jetson on our robot, and that allows us to run the operating system that we were talking about. It's called the Robot Operating System, or ROS. And we were the first team in our robotics league to use ROS on our robot. So we're going to talk about that today. And the NVIDIA Jetson has really allowed us to make this transition because we couldn't run ROS on the first required software.
So a little background about our team specifically. So our team is the Zebracorns. We're based out of North Carolina School of Science and Math, but since our founding, we've opened up being on the team to members from the community and not just students from science and mathematics. And as FRC teams go, we're ambitious out of the norm, trying to push to find challenge what's possible within our robotics league, making available the innovations that we develop on a team available to all teams in FRC, trying to increase our level of competition as well as the competition of every team in general. So a little bit info about the Robotics League specifically. We take part in an organization called FIRST, which stands for Inspiration and Recognition of Science and Technology. FIRST has multiple different competitions for different age groups. The high school competition, FIRST Robotics competition, is the one that we take part in. And there are over 3,600 different FRC teams representing 27 different countries around the world. And this competition has reached over 90,000 different. Here are some examples of robots in the past couple of years that we've built for this competition. You'll notice that each year the robots differ drastically in both design and function, as the first FRC game changes completely every year. We have to design, build, and program a new robot from the ground up in an incredibly limited amount of time every year.
So we mentioned that we transitioned to this to ROS, which is the Robot Operating System. So ROS is an open collection of open source libraries that make it easier for us to build robot programs. So essentially, it's a framework for passing data within code, and it also includes lots of tools and utilities that make it easier to build robots. So here on the left, you can see a graph of motor speeds over time, and on the right, you can see a map of our lab, which we made using a LiDAR and visualized using a ROS sensor visualization tool called RViz. So ROS is really widely used in both industry and academia, but it hasn't been introduced to the first robotics league until now. So why did we choose specifically to transition to ROS? So first, we run an NVIDIA Jetson TX2 as a co-processor on a robot alongside of the first mandated processor called the RoboRio. So the NVIDIA Jetson TX2 does high overhead sensor processing and other tasks, and it's recently transitioned to doing a lot of other really interesting things. We'll talk about that in a couple of slides. So ROS streamlines communication between the RoboRio and the Jetson, so that it's easier to transition like what code we're running into the processor. We also rapidly iterate through different sensor combinations, and ROS's code modularity and open source software packages make this kind of development possible. We have data acquisition capabilities with ROS, so we can record data in real time, play it back after the match, and we have unique capabilities to analyze that data because of built-in ROS utilities. And then, of course, we are really interested in automating the robot as much as we can. ROS's control packages, automation packages, and code modularity are making that dream more possible for us. So how did we get to using ROS? We transitioned to it last year, but in 2012, we began experimenting with stereoscopic vision using IP cameras. We were streaming all the data from onboard the robot to an offboard laptop to do all the computation, but we began having network latency problems. So in 2015, we transitioned to using an NVIDIA Jetson TK1 to run vision processing on the robot. In 2016, as Marshall mentioned, we sent a couple of students to the MIT VivaWorks program where they learned about ROS. And then the next year, we used ROS to communicate between our LabVIEW control code and our C++ sensors code. And then finally, last year, we transitioned to full C++ code for control of our robot, and we were the first team in FRC to do so.
So FRC robots are constrained by a lot of different rules, and first, the size constraints, usually around 150 pounds and 3 foot by 3 foot at the base, although this can vary from year to year. However, some of the strictest constraints placed on FRT teams is the maximum part cost, which limits the amount and type of sensors, processors, and hardware that we can run on our robots. So Olivia mentioned the RoboRio before, and previously all direct writes to hardware have had to come from the RoboRio, and I'll talk about that more in a couple slides about that specifically. Most teams program using Java, C++, or LabVIEW using the provided WPI lib libraries, which facilitate robot communication through the field network. And some of the WPI lib commands, such as enabling and disabling the robot, are necessary to legally run an FRC robot, and so we had to implement these with ROS as well. So this is our last year's ROS configuration. There's a lot of information here. I'm not going to go over it all. There's a couple important things that I wanted to point out. The first is based off of the RoboRio and how all the hardware had to be directly connected to it. So you can see our motors, pneumatics, and any other actuators we wanted to have on the robot had to be directly controlled from the RoboRio. And subsequently, all sensors connected to those, as well as any information coming from the field network, is also going into the RoboRio. So as you can see, a lot of our control code has to be running on the RoboRio as well, as it directly interacts with the hardware interface, communicating to the hardware. However, we were able to connect up our stereoscopic camera as well as the LiDAR to the NVIDIA Jetson TX2, where we were able to run the higher overhead sensor processing tasks to do some of the more exciting control and vision code as that communicates over to the controllers. This is our rough setup for this coming year, and in this new year, we're potentially able to directly write to hardware from the Jetson, while we still have to communicate all enable and disable and heartbeat threads from the RoboRio. We're able to send commands directly from the Jetson as well, which is why we have two hardware interfaces as well as two different controller managers. So we've had to split things up, but doing this has allowed us to run a much larger portion of our code on the Jetson, which is increasing our loop rates up to 100 hertz, as previously we had a lot of issues with lag. For getting the Jetson on the CAN bus, which is how we interact with a lot of different motors and hardware on the robot, we use the cannable USB to CAN adapter. And as I mentioned, with the RoboRio, has to send the heartbeat to stay FRC legal, while the Jetson, we're able to send the command and read the feedback from the motors and other actuators. We still potentially have the ability, if this doesn't work out, which it has so far, but who knows, to transition back to just running and controlling directly from the RoboRio, although we're hoping that this framework is going to work out the competitions.
So before we made the transition to running the Jetson on the CAN bus, we were offloading a lot of our processing, or we're still offloading a lot of our processing to these motor controllers, because it's impossible to run such fast loops on the RoboRio. So we use the CAN-connected embedded motor controllers from Crossroad Electronics called Talon SRXs. These Talons have the ability to run control loops such as PID with feed forward, and simple trapezoidal motion profiling, which allows less data to be sent to and from the processors, other than occasional feedback and set points. So this is what really made it possible before we had Jetson on the CAN bus to run our mechanisms. So we had to write a couple of custom ROS controller packages to interface with these Talons. So first, we wrote a package called Appellant Interface. It creates an object for Talon state and an object for Talon command. The object for Talon state stores all the data that we read from the Talon, and then the object for Talon command stores not only the set points, but also the Talon-specific configuration data. And then we wrote a package called a Talon state controller, which essentially takes data from the Talons and makes it accessible to all of the code that's running on both of our processors. And then we have a package called Talon controllers. The idea of the Talon controllers is designed as a replacement for the standard ROS controllers, so it's easy to modify a mechanism that's not Talon specific to be able to run with Talons, where all of like the back-end Talon configuration is not in that mechanism controller. So we wrote a couple of mechanism controllers that integrate our pneumatic actuators and our Talons and our sensor feedback. So one of them was our drive-based controller. So this is a module from our drive base. It's called Swerve Drive. The wheels can not only rotate, but they can also be steered, which allows for really high maneuverability. This also allows us to implement a custom motion profiling algorithm, which limits the velocity and the acceleration on each of the wheels. And then we also had, last year's robot, we had an elevator controller. This included a lift, an arm, and an intake. And Ross really enabled us to have this kind of complicated controller for two reasons. One, we were able to simulate the handoff of the cube, which is our game piece, between the different aspects of this controller. And then it also allowed us to automate the actions because of built-in ROS packages.
One of the really interesting things that ROS has allowed us to do, which Olivia touched on in the previous slide, is simulating our code off of the robot. So this previous year, we, in addition to transitioning completely to ROS, we developed a simulation interface that allowed us to run all of our robot code off of the robot on our development laptops with no connected hardware whatsoever. We did this with the use of a simulation interface, which replaces the hardware interface that I talked about a bit on the layout slides. But essentially what this does, it runs almost identical to the hardware interface, except it doesn't send any reads or writes to actual hardware. Instead, it simulates that data and is able to, it allows all of the controllers that Olivia just talked about to run exactly as they would if they're running on the robot. However, they're running on a laptop with no connected hardware. However, a lot of the code that we wrote relies on FRC-specific match data or messages that are coming from the field network. And these messages come from being connected through the FRC driver station. However, this driver station only runs on Windows and heavily relies on an actual robot connection. So what we did is we wrote our own simulation of the driver station, which you can see up here, which runs in Ubuntu, and is integrated with ROS using their built-in plugin for creating GUI applications. So this allowed us to fully simulate our robot without needing an actual robot, and along with this, the ability to visualize different mechanisms on the robot allowed for fully automated. I'll get to that in just a second. Along with this, transitioning ROS to a previously to a completely new platform, the Robo Rio, contained a lot of non-trivial challenges along with it. So first, we had to the controllers. We had to implement them ourselves for our specific use case, as well as getting ROS to work correctly on the Robo Rio, and the main thing was the controllers getting that framework in place so that we can effectively control FRC robots using ROS. But what the simulation interface allowed us to do was to develop this fully automated handoff between the intake and the elevator with all these parts that have the ability to intersect with each other and completely break the robot if it doesn't work correctly. But we were able to fully simulate this action before we ever ran it on a robot, so that we knew that when we put it on the robot, it would work and none of the parts would collide. And this handoff would not have been possible without the simulation tools that ROS allowed us to use.
So we also had the honor to give a talk at ROSCon, which is an international ROS conference in Madrid, Spain. We gave it this September. So we went and we talked about our team and what we had done and the challenges we had had and the accomplishment in porting ROS over to FRC, all the things that Niall just talked about. So we also got to attend different talks on the things that we were learning about, the motion profiling and path planning and then automation of robot tasks, all the things that we were really actively investigating. We had to talk to industry professionals and get advice on all the questions we were having. This is when we were developing our off-season robot, which is especially exciting. You can actually see our talk at zebracorn.link/ROSCon2018. Then you can also see all the other talks that were given at the conference. There were a lot of really exciting things there. I'd recommend you check it out. We have four main long-term goals for the future. First and foremost, we're really passionate about spreading ROS to the rest of FRC. and making it more accessible to FRC teams. So we think that if ROS is more widespread, it'll just raise the overall level of competition, which is good for everyone involved. We've already published 2 different white papers explaining how we did it and why we did it, and hopefully making it more possible for other teams to make the transition, or even to translate part of their robot code into ROS like we did a couple of years ago. We're also hoping to give a talk at the championship in Houston, Texas, to further expose our techniques and everything to more teams. We're also working on improving our robot localization. So we have a Z stereoscopic camera, we have an RP LiDAR, we have a couple of other sensors that we might not be able to use on the actual robot because they're above the price limit. But we'll use a robot localization to localize ourselves against field elements and place ourselves in relation to other robots and field elements and make a robot more autonomous. And then we're also working to improve our simulation. So we have currently a full-scale VR simulation of gameplay using CAD from a real robot written in Unreal Engine 4. We're hoping to integrate some of our ROS into that simulation. We're also hoping to broaden our simulation so it's possible to do more with them, and so we can iterate over them quickly. And then finally, we have a dream of deploying FRC's first fully autonomous robot. Again, like Marcia said, it might not happen tomorrow, but hopefully ROS will allow us to get closer and closer to this goal. And then last, we want to say thank you to all of our sponsors. There are so many, and there are more that aren't on this list. It's not warm yet. So especially the NCSM Foundation, and we have a last minute NCSM, so of course we couldn't do without them, and of course, thanks to NVIDIA, we couldn't run ROS on a robot without NVIDIA. So yes, thank you. Any questions?
First of all, it seems like we're doing college level time. Kudos. I guess maybe you can give us a better feel for the tasks. I mean, I'm looking at like how autonomous are these robots? Can you just like let them loose? Are you still just with a joystick? I mean, I feel like no, but at the same time, you know, if being fully autonomous is the goal, then it's not yet. So can you just kind of like flesh that out a little bit?
So in previous years, we've had a 15-second full autonomous period, and then maybe a 2.5-minute period with teleoperated joystick control. This year's a little bit different. It's all teleoperated joystick control. But really, right now what we're working on is automating individual robot actions. So for example, we might be manipulating a game piece. And so we want to automate everything from the moment that we intake a game piece and path to the place where we need to be, replacing the robot and everything. I mean, not replacing the game piece and everything. So the idea is that we automate individual robot actions and not the entire robot. That's where we're going at the moment. Kevin, do you have more to say?
That's a pretty good summary.
Okay.
Yeah. Find out who is associated with an FRC has experience with FRC. Let's have what audience reflected this in the okay. Right. There's quite a few people who use beyond who's never seen FRC being played. You've never seen one play. Okay.
Let's change that. There are 5 events in North Carolina. I beg of you, it's fun. If only for a day, come to it.
Yeah, just for a sense of scale, they're played on a field that's roughly they fit in high school basketball. But it's 26 by 27 by yeah. So, it's 3 robots on a side. You're competing to do a task. Game objects. It's usually about a foot around per thing. And it's typically a game where you do the same thing repeatedly. So that's kind of why our goal is to automate things, because a well-automated system is a lot better than
no, we all know high school students are freak drivers.
I've seen the commit logs at 4 a.m. I know what they do.
5.
So I run the underwater robotics team in the state, and I'm trying to convince my mechanical electrical people to switch to Jetson for next year's competition. What were some of the major challenges that you all had trying to migrate your existing software architecture move to a different entirely.
I would say that the biggest challenge was we hadn't written any raw code for controlling the robot at all. So we really had to build all of our entire code base from the ground up in 1.5 seasons-ish. So like just the pure development time was the was the biggest challenge. But the biggest challenge of using the new system was probably that, like integrating it with the FCC regulations and making sure all of communicating from the Rio and not Jetson for communication previous year, making sure all the communications were set up would probably be the part of the thing.
Yeah, I agree with that, especially the second part, which is FRC is pretty safety oriented. I mean, they're 150-pound robots who run 50 seconds, and my husband's good, so how much you can
Well, the same thing is everything else is really scary.
everything else is scary except for high school. Yeah. So there's a lot of safeguards built in to try and make shut the robot down any time they want. Incorporating those into our code, making sure they're all respect those. So great. That's yeah, kind of challenge.
You can just tell your college friends that when high school is good. If any of you are seniors or coming to state, we're going to have a lot of stuff. So, I'll briefly, the one thing I will say that I've seen kind of in all of this, we keep transitioning, and it's not just it's life in general or industry in particular, we keep transitioning to more and more like software. So this is just fun. So anybody, like, eventually at some point, it's FRC won't be a hard sport. Anyway.
I was gonna make a quick comment. It was really cool seeing the simulated all code driven data off device. You don't know how powerful that really is. I know you guys are promoting it here, but it's really impressive to see, especially from this stage. So I guess from a presentation perspective, is any of that with the course is disclosed? You guys are getting up. IDs already.
Everything from the previous year is on our GitHub. It's the repository FRC 900 2018 robot code.
Our website is FRC 900 FRC900.org.
Where's P100?
Or Team 900, sorry. Well, we've got that one. We have like 10 of them because we got all the main names.
Yeah, if you Google zebra cores, you should find our website.
Well, okay, perfect. So you already have probably more GitHub or GitXP than folks. That's very cool.
The Robo Rio has a heartbeat. Didn't let me shut down the power. Right? So we kind of
It's
correct part of that was wrong.
It's fucking good.
Yeah, the power stays on no matter what. The speed,
Okay, so what is it you have to keep running on the Robo Rio so that the field doesn't decide that you've gone rogue and shut you down?
You want the honest answer? A fake talent.
Yeah.
So, but it's completely and totally legal. So it's the best thing ever. So very legal, very cool.
So you say it's a fake talent, it's a software?
It's a software talent that we initialize to a random.
Yeah, you just create a talent object on the Rio, and that starts up some background process. It's out of heartbeat. So every so often.
So the reason we got this way, like how we changed the rules, which is important because I think a lot of teams approach FRC as though the rules are set in stone, they never change, and they never do anything different, and that's a terrible, it's a terrible way to approach life in general. So rules are there because they're rules, and occasionally they get to change. That's how it works. So these guys, in combination with a student who's not here, his name is Ryan Greenblatt. Ryan's at Brown. So Ryan interned with Across the Road Electronics over the summer, and one of the things he did was introduce Across the Road to the magical world of ROS. So, and in the process, what he showed them was that it should be possible for us to control all of these things while keeping the heartbeat on something else. So over the summer, Across the Road Electronics actually made a demo robot using a Raspberry Pi, not a Jetson. So if you're worried about how much all of this costs, you can do this on a Raspberry Pi, which is $35. Or $30, something like that, right? So running on the Raspberry Pi. They ran ROS. They connected it up to a CAN bus using a cannable thing, the same way we are. Still a USB widget, so USB CAN. It talked to all the motor controllers while keeping the heartbeat on the Robo Rio. Proved that this was viable. Now, as a result, Across the Road Electronics has libraries for every major platform, which is awesome. So,
You run the robot on a laptop now.
Yes.
Cross-compiled Rex 86, ARM, 64
Yeah.
ARM.
And it's coming for other things too. And then what also happened in conjunction with that was pestering the right people at Bush headquarters in Hampshire, who I don't know if they're watching, but thank you for changing the rules so that we could do this. The rules were never meant to not enable this. It's just that nobody ever asked. So when it came time for us to go, hey, can you do this? They were like, yeah, why not? And they're like, why can't you do it now? And I'm like, because your rule won't let us. So pointing that out to the right people got the right change we needed, which is kind of a cool story in and of itself.
How do your driver station simulation feedback, how does it come back? Like as a text or like?
So it's running on when we're running in simulation, we're running all of our code on the same laptop, and we run the driver station on that laptop as well. It's just a graphical application that is sending standard ROS messages and communicating directly with the simulation interface to send like fake match data, like how long is left in the match, is the robot enabled or disabled, autonomous, teleoperated, that sort of thing. It basically just communicates into our code the same way the actual driver station, once it gets to our code, interacts with our code.
Because you guys have it in a simulated environment, do you write any like automated tests for having confidence?
We've started.
Yeah, I think we have one working right now.
So
proof of concept, I guess.
One of the coolest things on that note, one of the coolest things that I've seen these guys do was last year, one of the students reached out to this company called Travis CI. So I'm sure people in the room know what this is. Travis CI is a company that does continuous integration stuff online. So it's an as a service platform for continuous integration where we had a Slack bot and we had Travis CI set up to hold down from Git whenever one of these guys committed. And then at 2 in the morning, the Slack bot would do its thing and compile the code, and then it post in Slack, success, failure, and these guys would do shaming as a service where they would make fun of each other with emojis based on who broke the build or who made the build work. And it was the coolest thing in the world because I spend all day talking to my clients about this notion of DevOps and what it means and how you get to that happy nirvana place. And here I have high school students in Slack at 2 in the morning doing exactly the stuff that I'm trying to get companies that are Fortune 10, Fortune 100 companies. Why can't you do this? So to me, it was like the coolest thing in the world to see that happen. And we're actually doing even more with it this year. Microsoft donated some money through their credits that we're now setting up a Jenkins server that's expanded with unit tests and other things. So holy crap, high school students are doing the things that I just talk about. Like, what's wrong with this?
Yeah.
So,
in general, ROS has support for Google Test framework. The challenge is we're doing kind of low-level hardware stuff, so to get that working, you have to have a lot of the simulation code giving correct feedback. The higher level nodes
You have that in place today.
we have a lot of it in place. It's a little bit tougher to do with systems that require like sensor input, things like that. But we're hoping to get there even further. But yeah, it's definitely planned.
Science and math is a 2-year school, so how do you guys continue to, is there like actual processes that you guys teach the upcoming students, all the hard technology and software that you guys use in your robotics team?
So it's definitely a challenge that we have as a 2-year school. For one thing, we accept students from outside of NCSSM. So I came on the team as a freshman in Riverside. And so 4-year students help a lot. We're working really hard to have really effective preseason. So if you don't know, with First Robotics, there's a period of time when our teams meet, but we're not building the robot for that next year because the game hasn't been released yet. It's called preseason. So in our preseason, we work really hard to make sure that we train new team members. We went to an off-season competition this year so we could train those team members. They could get experience driving the robot and programming the robot under a crunch deadline and everything. So that's mainly what we do. for that, and then for your team members. And we have a team wiki, which is in development always. We try to work really hard to do documentation. We have white papers that we said are not just for the FRC community in general, but also for us, so we can give them to our team members. Say, here, read this. It explains everything. And then we have a code from previous years, and yeah.
So we've gotten a reputation in the last couple of years of writing white papers, and I don't think people realize we started writing the white papers just so we could maintain knowledge. So that 2-year turnover, if you're the small companies in the room, or even the large companies, imagine losing 50% of your employees every year. That's what we did for a long time, and it was painful. It's still painful, but we've gotten better at it by documenting, by automating. It's part of why we do what we do. So.
Yeah.
Probably not that interested in the question, but is the TX2, does that have a fan or is it just passively cooled?
It does have a fan. There are passively cooled versions. The industrial version is passively cooled, and I think you can downclock it. So where it'll be okay without it.
It's soft clocks, the fan doesn't run much at all, but
yeah,
that's no problem.
Anything about the robotics corner?
Yeah. So this is our off-season robot. It's not the robot that we built during the competition last year. We built it in this fall to go to the. I was on video.
Yeah.
But we built and programmed this robot all this fall, trying with the goal of automating it as much as possible. We didn't quite meet a lot of our deadlines for that because we were at the same time trying to teach all of our new team programming members, mechanical members, and so teaching and building this whole robot was a little too much to fit in that time period. We're hoping for this next year, now that we have 2 years of teaching students Ross, that we'll have enough manpower to do this again at another off-season event. But we're trying to make this as automated as possible. If you know the game really well, there was the exchange, the logo. We were trying to pick up the cubes and deposit them in that goal. Fully automated. We developed almost all the code we needed to do that, but we didn't have time before the competition to test any of it on an actual field, on an actual robot. So it didn't succeed very well, but we got a lot of experience going through that process of trying to develop a fully automated robot, and hopefully this next year with that experience behind us, we can potentially succeed in that respect.
That's what it actually does. So there are these milk crate sized game pieces. They're bright yellow and they're power cubes, and so the arm moves like this, and then it spins, and then there's pneumatics, and so it intakes the cubes and then drives around and spits them back out again. And it also has a bunch of really fancy sensors. It had 2 Zeds on there, 2 Jetsons, a fancy $3,000 LiDAR that we wanted to raffle at RossCon, an RP LiDAR. There were maybe 14 Talons, therefore 14 encoders, 12 encoders. So, yeah.
How much do you meet in that preseason? You write about the preseason. How often does your team meet? How many hours?
Twice a week.
Twice a week. For 3.5 hours. Or 3 and a bit hours.
About 7 hours a week, 6 hours a week.
And granted, preseason for us this year, it's varied year to year. The last few years, we've kind of been nomads and had to move our space from one place to another. But this past year, we were able to go back to Science and Math campus, make a return, and it's been fantastic because we aren't going to have to move again for a little while unless they build a new building, which I'm trying. I'm going to get there. So, but it's awesome because suddenly we can start meeting. We met more in the fall this year than I think we did in the past 2 years, which is kind of awesome. So,
it was the second most aggressive off-season meeting schedule I think I've ever seen.
Yeah, it was pretty good. And the best part for me, this is the first year I've ever actually been able to take a vacation. I went on a month-long tour of New Zealand in that time period, and I didn't really worry about it. The students, the other mentors had everything kind of under control. It was awesome. So.
And there's no way we get everything done within those 7 hours. So like a lot of work still happens outside of the lab during that time, on Slack still, but whatever time that we deem appropriate to work on things, it's kind of when that stuff happens as well. So
which is why the raw simulation is nice because you can test the whole robot on a laptop any time of day and night, not in the lab or out of the lab.
Are you in the church at the PDC?
Yeah.
So I'm the coach of this team. I'm one of the two coaches of this team, and I want to extend an invitation, which is if you have trouble finding a place to meet for this kind of thing again, the Forge would be glad to give you space to do that. We think this is amazing, and we would gladly give you free of charge space to come host a thing like this. I want you to know I'm on the board
Fair
of
enough. That's actually good.
directors, and I'm extending an invitation.
That's good to know.
One comment I want to mention about teams, FRC is unique in that throughout the kind of qualifications, you get randomly assigned with 2 other teams to be part of your alliance. And so you really want to help the other teams because they may be your alliance partner. And then at the end of the qualification rounds, the top 8 teams get to select who their 2 alliance partners are for the final brackets. They go 8, 4, 2, 1. And so there become, like we were an alliance partner with Unicorns for one of the competitions last year. And so there becomes not this, I'm trying to beat you or I'm not going to share all my stuff with you. It becomes very much of a, we're trying to raise the competition of all the teams everywhere. And from a mentor and coach perspective, the guy that's the founder of FIRST probably said it best at South by Southwest, which is, we're not using students to build robots, we're using robots to build students. And so that's really our goal. And so that's why so many of the teams you see work together in ways that if you're used to thinking about stuff like a competitive sports league might be surprising to you.
Yeah, there's two terms that FIRST likes to throw around. The first one is collaboration, which I'm very familiar with, not just from FIRST, but also in industry. Like we sometimes work with our people, like we have frenemies, right? Like Nutanix and VMware, not the best buddies, but sometimes we gotta make our stuff work on their platform, and sometimes I gotta deal with us with our software on their stuff. So that's how it works. It's not that uncommon in industry to see these things happen. The other term that they like to use is this notion of gracious professionalism, which it means a lot of different things to a lot of different people. For the most part, it just means act like a professional. They don't want the experience of it being a little league game with a parent that's yelling at an umpire, right? Like, it's just a robot. I mean, yeah, they're expensive and they're fun toys, and the students are very passionate, and the mentors are very passionate, but we don't want to turn it into that. So we're better than that. Let's keep it that way.
And honest to gosh, you're likely to find you work for this company,
yeah,
and 5 years later, you're working for a company that seems like the worst competitor ever, and you want that job really badly, right? And it'd be good to have been graciously professional while working with them, wouldn't it?
Totally.
So I know this is a new DDS piece of hardware, and I wonder if you have any plan to make use of that 512 pole?
Yeah. So I worked on a project that I'll present on soon. But yeah, I ended up using this and I put it on another system on a drone actually, and did some autonomous flight with that. Hoping to.
Specifically the Xavier, what are we going to use it for this year?
Yeah, so the Xavier are actually going to throw on our pit, so where we fix our robot and do all their stuff. ROS has a cool feature called ROS Tag, where all of the data that we get from all of our sensors gets ported into a file and saved, and you know what time it was and when it was released and everything. So I wrote some visualization code, and so we're actually going to throw that on the Xavier and have like however many graphs we end up needing or wanting to show everything on some big screens to kind of go and make sure that a robot's working, and well, not make sure, know what's wrong with the robot and fix that. That's what usually ends up happening.
If you've ever seen Formula One football, like imagine that's kind of what we're aiming for at some point. I don't know if it'll happen this year, but at some point in the near future, that's the end goal, is to create this massive display of data and visualize it in ways that we hadn't been able to previously. Unfortunately, the cost limit means we can't put it on a robot just yet. I suspect that will change, but in the interim, we can make use of it. So we do have the ability to put it somewhere and try and use what we can on it. I doubt we're going to come close to tapping it out as far as the GPU cores go, but the 8 CPU cores will get to work out, and we'll probably do what we can with it. So
are you using the CUDA language or using other language?
So we
Yeah.
For
now we're
I mean, we use it for the Zeds at the moment. I think is the main thing. It's just a package that employees using CUDA. We haven't written any ourselves. We've debated it for a couple things on whether or not we wanted to, and we definitely have the ability to. I think right now we've got 20 different languages in our code base for everything, so we'd be okay adding CUDA if we feel like we want to.
Yeah, so the Z is a service on the camera, and it's specifically used as the end it's used for reconstruction. So we definitely use it for that. We do have a little bit of CUDA code that we did in like 2016 for object recognition to accelerate certain parts of it. It just depends on the task we do for this year. If we're going to be heavy into vision code, object detection, we'll probably end up using it, but I'm thinking this year probably doesn't lend itself to that.
How about Python? I mean, I know Python has a lot of machine learning libraries. And since you only mentioned about C++, Java.
Yeah, we have the ability to use Python with ROS. That's one of the supported languages, and some of the nodes that we've written could use it. I don't know specifically about findings and machine learning side of things, but it could work.
It does get funny with like OpenCV only recent introduced findings for CUDA for Python. I think that's been one of the holdups with a lot of stuff is that the OpenCV findings just aren't there. So one of the problems that you have with OpenCV with GPUs and CPUs is you have to take stuff that's in memory on the CPU and figure out how to get it in the GPU memory. And yeah, it's a costly process. What's cool about the NVIDIA embedded platforms is they simplify that process a little bit. So with some of their libraries, unfortunately, the bindings just don't exist for like anything outside of C. So for the most part, it kind of varies. And it's wishy-washy because there's lots of random GitHub projects where people have started something like, I can do this, and then they hit a week into it and realize, no, this is actually a very hard problem to solve. So it's hard to know how to optimize. In fact, we've run into this ourselves. Sometimes it makes more sense to just run the OpenCV operation on the CPU. And it doesn't make sense to try and take the hit for transferring it to GPU memory. So
But I think it's a lot where you're worrying about things like warp and grid dimension and things like that. And memory management on the GPU.
not really. No. Not yet.
Oh, not yet.
So I think we'll get there though.
So just by the nature of having multiple processors and also a driver station, there's a lot of networking going on. And I know that the field management system can really throw quite a wrench in that sometimes. So does ROS provide any tools for monitoring the network, either post-match or during the match, to figure out what's wrong?
So we kind of wrote our own. They have ROS nodes, publish topics, and then, as Mason said, ROS bags subscribe to those topics and they store them. So we have both the RoboRio and the Jetson continuously publishing a heartbeat node. So we can tell, we'd have just a complete, for the whole match, did we lose connection at any time. We were having problems last year because we were losing power to the radio, or we were losing power, we're losing power to the radio, the Ethernet switch. Yeah. So we're using that to debug our networking problems.
But the other part of it is, so a lot of that CPU load hits on the RoboRio. By moving as much as we can over to Jetson, that frees up a little bit of capacity on the Rio to have basically dedicated CPU on it. So there's like one of the Rio CPU is network communications, the other one is the basic robot stuff, and everything else is all on Jetson.
So to put it in perspective too, the Rio is two 660 megahertz ARM Cortex A9s, so 32-bit ARM CPUs. It costs $435, and that's the discount to FRC teams. The Jetson TX2 cost, the dev kit for EU pricing is $299. Even at the dev kit, it's something like $500 outright. If you're an actual developer, you want to buy it and you don't have the EU discount. The Rio, if I remember from NI, is like a $1,200 device. It's very different though. It has an FPGA on board that you can do a lot of stuff with, and it's really designed for real-time processing. But I know which one I'd rather spend money on. So,
what does the connection look like between the Jetson and the RoboRio? How are you connecting them? What's the architecture look like? What's that?
So physically, they're connected over Ethernet. We have an Ethernet hub on the robot so we can connect to a switch. We can connect the Jetson to the Rio and have ports left over for programmers to plug into the robot to deploy code or to debug some things. So physically, this is just Ethernet, but And the ROS communication between the two is essentially TCP packets, right? It's networking. It's networking. It's sending them over Ethernet, and so it can every message it publishes can be read both locally and anywhere else on that network.
Where does the official switch that they give you that communicates with the field plug into all of that?
Plugs in off of. So we have
So you have a switch and then that switch.
Correct.
So your switch doesn't go straight to the RoboRio. It goes to.
You can. I don't know. It depends on the robot and what we're trying to do. But from an architecture standpoint, it's an unmanaged switch, so it's basically just extending the force from the main radio, so the open mesh radio that's on there. So in fact, we probably got all of that on here. If I had to guess.
All the inside though.
For some years,
yeah,
you
it's all
haven't been
inside.
able to talk between the two ports, right? So I was just trying to figure out how to make that work.
So yes, that is a problem we have had. There are things I'm not supposed to say because of NDA agreements. I don't have the NDA, but you don't. You can talk about it. It solves my problem. So.
That was a bug in radio firmware, and there are ways to work around it by using older, previous year's radios, and it would work correctly. So it's not an intended.
That isn't intentional. That was just a behavior that
Yeah,
existed.
there was a rule update that they said suddenly you could plug your RoboRio directly instead of plugging both things directly into the switch. You could plug them both into another switch.
That's what we didn't see. Okay.
Yep. That was.
That's what it sounded like you had to be doing. Okay.
Yeah. Yeah. I might have yelled at some people when that update happened. So. Yeah. Anyway.
Thank you.
Somewhat unrelated to Ross, but in your architecture diagram, you had haptic feedback from the robot. What's going on with that?
So that is a project that we're working on. We have lots of side projects, but this is kind of one of our more exciting ones. Mason can probably talk to it more than I can, but we had, yeah, go ahead.
So we had a couple people develop some motors or some boards that held phone vibration motors, just a couple of them, and over some CAN, I think is what they ended up using. I2C. They connected them in a string, and so actually we can plug it into the driver station, and we get the information back from the robot, and whatever we decide is important, like whether or not I have a cube or whether or not it's in position, we can actually buzz certain motors at different frequencies. And so right now they're working on a vest right now for whoever's driving the robot to wear. And so at different pressure points on their body, they can determine different things. And so if we have a drop-in network or does something completely wrong. We've considered maybe electric shock instead because it might be more.
We make all the students sign agreements for us to do experiments. So there's an awesome. I will mention the inspiration for this really started probably 2014, maybe 2015. There's a TED Talk and it's a few TED Talks at this point, by a guy named David Eagleman, who I believe was at Stanford, is at Stanford. David Eagleman's done these research projects involving sensory addition. So basically adding senses to humans and augmenting senses for humans. And in particular, one of the things they've done is a vest that allows blind people to see, and then a vest that allows deaf people to hear, and it translates noise sent to someone using basically a phone and a microphone and a Bluetooth connection into vibration patterns for the vest. And they've noticed, even over the course of short duration time periods, that people can start to kind of gain intuition about it. And it turns out that one of the things that's cool about human skin, human contact, is that it's very susceptible to short pulses and bursts using vibrations. So you can get it all over. So suddenly you can start tracking things just by the way it works, which is kind of cool. So it's led to these research projects. We never know, so I guess I can talk to that as a mentor as well, but we never know what the students are going to come up with, and we never know what's going to be valuable. Sometimes they get off into La La Land, and I'm trying to think of one that has gone that way, but I don't have one off the top of my head right now. But occasionally they'll go off into something and it doesn't work, and the experience for them is learning that, hey, it's okay to fail, and I just wasted a bunch of resources on this thing and it didn't work. Other times they go off and they develop a VR simulation 2.5, 3 years ahead of when headquarters is finally doing it. It really varies, and we don't know what works and what doesn't until we try it. So, and that might sound very familiar to a lot of people who work in R&D departments science. Like, you kind of throw things at a wall and figure out what sticks. When you're working with high school students, it's a lot of fun. They have no idea that we have the resources we have, but they're like, wait a minute, I can get the things that I need to do this? Yeah. It's kind of cool.
So for this year's robot, you're using LiDAR. I'm just curious, what's it for?
We're not really using the LiDAR. We were using it in the off-season competition to collect data. We actually might be, probably not. If we were to be using the LiDAR, what we'd probably be doing is detecting lines and then using it to orient our robot against the, like for example, right now there's a cargo ship. We have to like straighten our robot in regards to the cargo ship. But we have probably a better way to do that since there's tape on the ground that's easier to orient against.
I'm wondering for the people that are not involved with FRC, would you be interested in seeing? There's a relatively short, like a minute video that shows you what this year's game is.
Yes. You can use it more as just an expensive distance sensor. So I think one of the, like what you mentioned, one of the tasks is to line up flat to the wall or right from the line. We were planning to use it for that. So we just get the wall and then drive us until it's flat.
He's asking how many students are on your team, and I'd like to tag on to that. How many of them are specifically involved in
all right. Our team, so our team is probably about 40-ish, 43-ish students, depending. Total, we have about 18, 19 programmers. And when I tell you that I have 18 or 19 high school students programming, I really do mean we have 18 or 19 students contributing to GitHub projects, submitting code, checking in, all that good stuff. That's insane to me.
We have 3,000 something commits right now.
Yeah.
Yeah.
It's kind of wild.
You guys have a code review process?
In fact,
we started
not just code reviews.
Yeah, we started formally doing code reviews this year. We're as like the whole team, like development process and structure, we're trying to implement a lot more industry practices in how we're developing, reviewing what we're working on. So we had our first code review a week ago.
Yeah, a week or two.
Yeah.
Sounds weird during the season.
Yeah. And currently, the main goal of these is to not necessarily go through like actual syntax of it, but to talk about how we're planning on hooking up different nodes to each other, the logic that we're going to need, and who's working on it, what resources do they need to get to what we need to get to.
And it also works well for teaching the entire team what's going on in code. Yes. 15 different people working on different things. So like put together.
You can learn a bit more about who people are with your code review. Take it seriously and be careful.
Yeah. That's probably the most polite code review in history for this one.
Yeah. This is true. And we're not just doing code review. What else are we reviewing?
Oh, we're doing design reviews. So we count our robot and then we go in and we tear it apart and like, this is why this is wrong. This is why this is going to break. And then, supportive and everything.
One of the students who went through this process class, he got out of it, and I actually was talking to him afterwards. I'd been over elsewhere machines parts and came back. I was like, how'd it go? And he's like, I feel like my brain has been sucked out. So it gets.
That was the one where there was like a 4-page document of all the things you fix.
Yes. So it's we're building a prototype product effectively. So it goes through this crazy process and it gets better. And you do it the first time and it's miserable. It's like code reviews. I mean, it's miserable. It's awful. Then you get to the third one and you're like, oh, I know what they're going to pick on me for. It's that I didn't label this and I didn't do this and I got to fix it already. Done. So.
You go through the animation real quickly. It's pretty short. Is there potentially audio?
We can overview. It's fine.
Yeah, it's alright.
Can you speak to it?
Yeah.
Explain the game?
You probably better like 50.
Welcome to 2019 First Robotics Competition.
There are captions if you can read them. I mean, the animation will show it pretty self-explanatory.
So it's like a 54 by 27 foot field, 3 robots versus 3 robots. Do these 2 things that they're showing in the video.
And then at the end of the game, you can get points for climbing onto the platform?
It's ascending a 19-inch vertical platform with no help, so no big deal.
These are some of the game pieces we use. The orange balls are called cargo, and the yellow circles are called hatch panels.
And you start the game on either the second level or the first level here.
And you can preload game pieces in the beginning of the match. Wear spacesuits.
Not really. The first 15 seconds of the match, you can't see what's going on in the field, although you can put cameras or anything else on your robot to help control your robot teleoperated.
We used to call that the autonomous period.
Yeah, it used to be fully autonomous for the first 15 seconds, but this year they didn't want to go that direction.
Yep.
So, yeah.
That's autonomous or tele up with cameras, right?
Yep. And then you can, vision's restored, and you can put game pieces onto the field or intake the ones that are already on the field.
And so the whole thing lasts about 2.5 minutes.
So
the round game pieces fall out with the hatch panel.
That's right.
Also
Yep.
There, so you have to coordinate both, and that's where the coordination comes. If one team can do hatch panels, and the other team can do balls, cargo, then you have the team. Alliance.
The Pyrotech really wants whatever the device is they have that allows the wheels and the legs to just drive.
Yeah.
That would be a really nice
We keep looking at anymore, we can't find it.
That's an overview of our game, right? Sorry, do you have a question?
Yeah. So you said you have 40-ish students. How many are part of your school? You know, juniors, seniors, and how many are what? And then how many are freshman, sophomore? Is that the age range that's allowed for this, or how?
Yep, it's freshman through senior year. Marshall, it's about half NCSSM students and then half non-NCSSM students. But it kind of changes from year to year too.
So all the NCSM are junior, senior, and then the other half are kind of split between all four.
Okay. Yeah. And then do you guys get full time to work on this stuff?
No.
They
what you want
definitely
during
don't
class.
respond to Slack messages during the middle of class.
No. That's
Just
really
like
good
I
student.
don't do it during work hours. Never happens.
Any other questions? Okay, awesome.
Did you have one? Oh.
Thank you.
Thank you very
Absolutely.
much for providing space.
Yeah, but we're not done yet.
No, Mason's got the whole thing, and then I have some more stuff to give away. Yes, and please come look at the robot. It's not just here to sit in the corner and look ugly.
If we pull the chairs up, can we drive it?
Yeah, maybe.
We can do it a bit. We've got this stuff.
They're saying yes. I'm worried because I don't care. I don't own the building.
I see.
It's only like 100 pounds, and it doesn't have bumpers, and it goes quick. So I don't know. Maybe it'll be all right. It'll be fine.
It's a 30 commits.
That's true. There's Sure. All right, Mason, take it away.
All right. So I'm Mason Mitchell. Marshall introduced me earlier. So this is not necessarily part of FIRST. It's kind of a tangent off of that. So I got into ROS last year, not necessarily part of the team. As you said, I did FeverWorks over last spring, and so I kind of did their version for autonomous cars, and then I went to MIT over the summer and kind of did some stuff with some drones. Not with ROS, but kind of just some signal processing work. But essentially, this project was done over the course of the beginning of this academic year. We had about a week where we had unplanned no school during a hurricane. And so it was me and Niall and Olivia, we kind of worked on this for about a week. So it was an overview for us as well, kind of as we did this. So it's not nearly as in-depth. It was funded kind of by me personally, and then the team donated a Jetson for me, so I used that, and then kind of some space at Science and Math. So this is like weeks worth of work, but it worked out well. Now you've done it. Ah, it did. All right. Yeah. So this is the main plan that I had for the week. that we had. So we started by building a drone. Then we wanted to add some Jetsons and some sensors, and then we put Ross. And the big main goal was to fly this autonomously, which we got close. We're not quite there yet, but it was a lot of fun. So we used Ross Flight, which was a package for Ross that we didn't develop ourselves, but definitely was very useful in actually making this work, because otherwise it wouldn't have happened. But it was open source, so we were able to edit all the stuff that we needed to and actually make it work with our own system. But yeah, basically it had none of the autonomous features itself. It was basically plug it in, connect it to your flight controller, and then it would actually be what allowed you to communicate with the motors on the drone and fly them. And so it had like basic control for making sure it was somewhat level and integrating with the gyro. But in terms of actually like fly from point A to B, it didn't really have that. But that kind of stuff was designed to be added on anyway. So this is kind of the main system of what we had. This is kind of a diagram from them on what it would look like, which is roughly what wiring ended up being. So I disassembled a different frame that I had for a racing drone and added some parts for actually holding the TX1, but I used the TX1 on a J120 board, which is actually what we use on the robot. So it's a lot smaller than the big dev kits that NVIDIA gives out, just because it's hard to put that on a drone that's 250 millimeters for the fans. We use some motors for us, just some more technical things. I use a Naze 32 flight controller, so essentially we needed some more sensors that are just on the Jetson itself, and so the flight controller is actually what talks to the ESCs. They're the speed controllers, which are the motor controllers for the actual brushless motors. And so we had to have some stuff running for Ross, both on the Jetson and on the flight controller to talk with each other, so we can kind of get that working. But yeah, we also put an Intel RealSense camera on there, which we played around with a bit. It's a little difficult to run with the TX1, but I got it working at some point and was able to do some fun stuff with it kind of off to the side. Yeah, so this is the build. I am less programmatically capable. So I started basic for me, which was SolidWorks. So all of this was modeled in SolidWorks, so I kind of knew what it was going to look like. It also let me balance like center of gravity, and it gave us a model for later if we wanted to throw it into virtual systems. We have something that is physically accurate to what it actually is in real life. So that was actually kind of cool, useful if we want to do something with it. There's a picture from the Fab Lab, which is a space we have at Science and Math, which is kind of where I assembled all of this. So we've got, this is a buck boost converter for the power that I have to have. This is actual J120, kind of disassembled. Don't worry about that, Marshall, it's fine. You got it back, right? Great, that's good. Works. It's fine. Yeah, and then the drone itself, which was kind of cannibalized from a different project, but for the most part was kind of rebuilt during the first couple of days that week, but it worked, so. Yeah. So this is a finished drone. There are a couple parts on here that are custom. We had to have a mounting bracket for the buck boost converter, and then this is actually a laser cut part on top to house the RealSense and the Jetson. So that's actually kind of really cool, integrated on with the own mount that's there. None of this was really designed to go together at all, so I'm glad it did in the amount of time that I did it in. But you know what, it's great. So how it works kind of from a more technical standpoint, the Ross flight is fairly safe in the way it runs. And so the Ross core actually runs on a bunch of laptops outside of the actual drone system itself. That way, if something goes wrong, you have a way to stop it. And if it disconnects, then it's also going to stop on its own, which is actually really useful, which you'll find out later. But yeah, there's a Ross node on the TX1 that'll kind of do all the main high-level, low-level control stuff. And that's kind of where the main processing works for everything that we're going to do, and it integrates all the sensors that aren't the gyro, which is on the flight controller. And then we have the one on the flight controller, which basically is just sending all of its information back to the TX1 and then receiving whatever it needs to tell the motors what to do. So basically the meat of it was on the TX1, and that's kind of what allowed all of this to happen. You have to have a second controller because otherwise you definitely don't have enough processing power to run this stuff. So Jetson was nice to have. But along with that, we had to run a Wi-Fi router to connect our Ross core Ubuntu to the actual drone. So the J120 board came in handy having wireless capability. So I hooked up some old Apple router and got that working. And then we have just the regular radio transmitter that's working for the drone. That's just connected straight to the drone, standard from what you would regularly assume. And that just goes straight to the flight controller. So from there, it actually executes actions by sending those signals back to the Jetson. It processes them, and then it sends them back to the flight controller. And that's just over USBs. They're connected, other than like Ethernet, which is what we have on our robot. And then we just have the RailSense camera, which is USB-C, and that's just hardwired straight to the Jetson. And we get our data from there, and then we can do whatever we want with it and then send commands to the drone. So it worked. This is a night, I think it was Thursday of the week, that we actually got motors spinning on the drone from Ross. So this drone is actually running Ross at this point and is able to control the motors, which was a great success. We were very happy at this point. This is at our gym because it's pouring outside because it was during the hurricane. But we needed power, and power had gone out in the building we were in, so we switched. But it all was great. This mainly happened due to some motors going backwards compared to what we thought they were, and some PID values for actually controlling leveling. So we were actually kind of easily able to fix that. And so later, the next day, we got it running. And this is the maiden voyage. And it does actually fly. And it's just manually controlled at the moment. But we were able to get it flying, and that's running with the controller. And we've got a laptop off in the background that's connected to this modem here that's talking to that drone. And so, not very thick. It's a blanket, actually. We learned from the previous mistake that when we flipped over, we broke these two propellers in the front. So we decided that if we put a rug there, we'd have less of a chance of that happening. Which, not shown here, is it flipping over on the rug and surviving. So we did tumble a couple Jetsons a few times, but just the one Jetson a couple times. Yeah, so that's the main feature for the Ross stuff, is it's doing. No, so at the moment this is kind of just base control for it, and getting kind of the basis for everything that can be built upon was what this kind of was at the moment. And I'll get to what you could end up doing with it and what work can be done. But my station's being reassembled. Yeah, so once again, along with the stuff that we do for our team, we can actually do all of this simulated. And so all of the code for Ross Flight can be run, and we can have it in Gazebo, which is a simulation software that integrates really, really well with Ross. And so all of the control that we do there can run in a physics engine on some other end of standard drone that was actually provided by Ross Flight, but we could actually add in the model that I created. And we can do all of our code systems in there. But we decided that flying inside in like a hallway was never the best plan that we had. And so going to autonomous control or simulation made a lot more sense than kind of going that route, unless we found a designated space to do that. And so at this point, a lot of it will happen virtually until we're confident that whatever pathing we have that runs autonomously based on, position estimation and path planning and that stuff works here first, instead of, starting it and the drone flying off in the distance, which is a lot more likely now that it works and does fly. Yeah, so kind of plans for the future. We have the RailSense camera on there, and I did some playing around with it, and it does work. So I've actually run some V-SLAM with it, which is just visualized SLAM. So I think it's visual, some things, localization and mapping. Basically, it's using those two depth cameras. It's generating a map of the area, and it's using that based on what it sees currently to do position estimation on where it thinks the drone is. And so we can use that along with the gyro that the J120 board has on it, and the one from the flight controller, and we can do some Kalman filtering and get a better estimate of where our drone actually is, which you kind of want to know where your drone is when you're flying it around. So that's always good, but basically we go with that and we do some lazy theta star path planning, which is just a theory at this point. It does work and has been proven to work. There's some ROS packages actually that we could pull that do exactly almost this, that use Octomap. And so they can take data from the the real sense controller, and they'll put it in the octomap, and then you can set points, and it will path around. Basically, what this means is it's finding the smallest path with blocks, and so it's like your 3D space. It'll make them into cubes, and at each intersection between all the cubes is a point, and so it'll draw the shortest line without hitting things that it say are blocked, just with the path planning. And so that's kind of the easiest way to do things in 3 dimensions. If you do them in 2 dimensions, then you can just do some other simpler path planning code, but that's boring, so got to go 3 dimensions. Yeah, but that's it. Once again, this is like a week worth of work that happened in September just because we had a hurricane and we were bored. But yeah, are there any?
What I mean, like students turn up with random stuff.
Are there any questions? It's definitely an overview, but yeah, let's start here.
So how much of you, in the space that you have, how much of that do you need laid out beforehand? Do you need to know where buildings and trees are before you're doing your planning, or is that being done live?
So that could be done both ways. If you could start with the map beforehand and then fly around that map with set points enabled. But definitely with something like VSlam with the Jetson, you could probably generate the map on the fly as you are going from point A to point B. So if I set something like 5 meters that way and I have no map of the area, then as I'm flying, it can generate that map, and then using some of its own path planning as it's flying could navigate around obstacles. So it could work both ways. But definitely the first way where you have a map beforehand is definitely better and safer. But I don't know how much of a priority that was this week, but any other questions? Yeah.
Currently, how long does your battery last? Because it seems like you got a lot of stuff.
Yeah. So I think this was a 1300 milliamp hour 4S battery. So it lasted about 3 minutes, which is actually fairly standard. I wasn't really expecting anything longer than that. But you could definitely go to a bigger base than this. This was designed for racing, the base was, and so everything that was on here, I was actually kind of surprised it flew with all the things I had to add to make it actually run this. So I was pretty impressed with how long it actually lasted. But you could put it on an octocopter and be a lot happier with flight time. Yeah. Yeah, you could. Once again, we haven't done the autonomous part yet. It's mostly been in simulation, and so I've done a bit of work on that. But yeah, it would be with obstacles, and so you could continuously run your path planning code as you're flying from location A to B, and it could regenerate paths based on what it ends up seeing in the way. Yeah.
How long did it take you to tune
Tuning KD didn't take very long. It took me probably 20 minutes because I didn't care that much. I just wanted to fly, and so it definitely could be better, but it's just a bit shaky if you don't tune it perfectly. So I was kind of okay with it. Yeah.
You said you based this personally?
Yeah. So the stuff that was mine was basically just the base drone. So I had the motors and the battery and the board, or the frame, and the flight controller. And so I actually got from the robotics team the Jetson and the real sense controller donated for a bit of time. What? Oh, it's from Marshall specifically, but it was in the lab, so I was like, hey, that works. You got that back too, right? Yeah. Great. But yeah, I gave it back. This is more disassembled at this point, but we got to the point where we know how it works and stuff for simulation can continue, which is basically what we're doing with our own robots, but we can just do it all autonomous until we're happy or find a place that we actually want to fly around. Yeah.
More swag to give away. So.
That is a question.
That's a
Yeah.
So right now you've got a radio talking to a radio receiver.
Yeah.
When you plug in the autonomous parts, how are you going to interface that? Are you going to keep a receiver just in case for fun?
So it would be an and/or kind of thing, or it'd be an or kind of thing. So it would either run autonomous and it's got dead zones on the radio and what it decides it actually should input. And so the way the base ROS flight is set up right now, if you input something as an autonomous command is being run, basically it's just setting set points for the motors to go to. And so it'll just override them and cancel autonomous actions and just go from what you have user controlled, which is a lot safer than what it would be if you just said go and do things autonomously. But yeah, it would be fully autonomous. But stuff the drone won't enable and let motors spin unless you have a controller running and ready to flip a disable lever.
Like flight controller, controlling receiver.
Yeah.
Flight controller.
No, it's still the flight controller, but the data from the flight controller that it gets from that radio receiver will go to the Jetson and then get processed and then be sent as commands to the motor, because the flight controller is basically just being used as a bridge to the Jetson from the Jetson to the speed controllers for the motors. Yeah.
Dumb question, but are you going to continue working on it?
Yeah, so it'll mostly be simulation now. As I said, I gave some components back because I wanted them, but I have a model of the drone that's actually fairly accurate in terms of center of gravity and stuff like that. And so you can actually come pretty close to simulating that in Gazebo and actually making all of that control system stuff actually working. And so probably the next step would be pulling in the packages to do a couple of these things on the board and trying to apply those.
But that might be after.
Yeah.
Maybe.
Depends on the way of the hurricane.
I just want to say something to how this is. So there's a group of IEEE engineers that do the humanoid robot project, and they meet in the same space that Pirate meet. Tuesday nights, by the way, if they want to participate. But they're exploring, I think they're using DSNAM instead of DSNAM. I don't know what the difference is. It's totally beyond me. And they're using ROS and developing ROS, and they're doing an autonomous robot that's meant to drive around the halls and talk to people. But they're using all the same technology, and these are people mid-career trying to get their skills up. So, I mean, this is really amazingly cool. You guys are way ahead of the curve. Super, super cool. And if you want to come help, they would love to have their help.
Yeah, I've talked to a couple of them into the Forge, right?
Yeah.
Yeah. I think the DSLAM stuff is basically you don't know any localization of where you are. And it's with a regular LiDAR instead of visual stuff. But
Right.
so it's knowing less and doing roughly the same thing with some more guesses in the way. Yeah. Yes.
How sturdy is PX1?
It's very sturdy. It didn't break.
It survived being on a first robot, I think at least once or twice before it ended up in your hands on a drone.
It
So
did.
It's
Yeah.
I think the only time we had a problem with it, we actually dragged the power wire across the ground for match and sorted it out that way.
Yeah.
But then we just replaced the power line. Plugged back in.
What about collision with the wall? Is there any structure, anything?
I think the worst you would do to it is probably if you've got it in some kind of case, like I'm gonna take this off the robot, it's gonna cause all kinds of problems. If you put it in a case kind of like that, which is totally open source, you can go rip off and all that good stuff. This is specifically designed for the J120 carrier board and the J200 phase 2, but we haven't really had any issues. It's been banged over all kinds of crap.
And you wanted to drop it?
I'm willing to bet it's gonna work. So I'm not gonna drop it from here, but I'm willing to bet it's. They're like, no!
I know.
They put it on a robot and it's been through far worse. So the brakes.
Yeah, direct collisions at like 10 miles per hour are fine without the case. So it's fine. Sturdy.
I'll be honest, if I wasn't willing to do that, it wouldn't go on there. So
Is this going to stay in touch with like the alumni network of previous students and we can try?
we're actually trying to do more with that. Corinne, who was one of the other students, probably talk about some of that, but that's okay. We are trying to do more of that now. So when I was a student, I was as well.
So how long, have you been operating at a very high level? How long?
Wow. A lot of stuff started, 2012 was kind of a bit of a starting point, but then really and truly, things really started picking up, which I think is when Joe here came onto the team. So I'm going to give him a lot of credit for this. I really do think having a passionate faculty advisor helped us to kind of more fully utilize the resources he has.
And that in turn has helped us to pull in more sponsors, which in turn helped us to grow, which in turn helped us to pull in more students. And then you create this feedback cycle that keeps going. And then this crap happens, and before long, you're in the grid with students. And I don't know, like it's insane. So he told me when I was a student, I'd be doing this still, mentoring these guys, going on half trips to a robotics conference where I watched a room of like 400 roboticists start pulling out cell phones to take pictures of their slides. No, I wouldn't have believed that when I was a student. Now I'm like, yeah, duh. Like, that's the coolest thing ever. Of course they took pictures. So,
yeah. As robotics goes on, is this an order of magnitude, say, harder than, say, getting a whole autonomous car driving around? Or, I mean, is it, when you move into like 3D world and drone world, I mean, is it just like a next level kind of thing, a quantum leap? Or is it just like, I'm probably harder, but maybe at the same?
I'll let Kevin talk about the autonomous car part, because I know he knows a lot about that. But I'm fairly certain, like, it's not that much difficult. You're just adding a dimension. But no big deal. If it helps specifically with our robots, we swerve, and so we already go in all directions on a 2D plane, and so that is less of a wow, that's new thing than working with a drone. And so yes, it's a lot harder to actually get control systems to work. There's about 20 different packages that will run a drone on a plane, and there's about 1 or 2 that actually have something that works with 3 dimensions. And so a lot of that is based on where the drone thinks it is and how that stuff is still happening right now in research. And so that's part of why that's kind of fizzled is to go further, you're going to have to go into what people are currently developing right now. It's kind of hard to find stuff that is like more robust than, hey, this does work on our system. There's not really anything developed for like anything standardized yet.
Although something that so like there's the idea of like turning in ROS packages, that's kind of what makes it possible. It's actually not that bad to go to start like working on things in a drone system because other people are working on things.
Yeah, I feel like Ross is doing a lot of the,
yes.
You're not hand calculating the equations to do the load balancing in flight, right? I mean, Ross precisely is doing that for you.
Yeah, so that's part of the ROS flight package and just stabilization in general. And that's just like the basic drone linear algebra work that's just being done.
That's one of the, I think, in the time I have been involved in diversity, I see it every year. Teams reinvent the wheel for programming. They have their own frameworks they bring. Don't get me wrong, there's nothing wrong with that. I think it's a great learning experience for every student, every team to build their own software framework, build their own way of doing stuff. But we can't effectively right now, you guys build code that we can't use. I mean, your robot's different, your code's different. That's fine, but why can't I reuse that code if I decide to build that robot and things get kind of messed up? There's no API framework. There's no like way to have things communicate different ways. There's no sharing code bases, languages. Some things you use Python, some Java, some Plus, LabVIEW. There's no commonality really between them, and it's frustrating. Like we're wasting so much energy trying to create the field. And yeah, there's something to be said for learning that process. So man, wouldn't it be cool if we could advance a whole lot further? And ROS is kind of the thing that's suddenly able. Part of the big reason the driver growth to platform.
Yeah, and I think this is a huge example of that. Like you're able to do this in a week. You could never do that with like something regular. You're like, I'm going to code this from scratch and it's going to fly around. And the amount of code comparatively that I had to do versus what someone else would have to do is like nothing magnitudes different. And so it's definitely the fact that ROS allows you to do that sort of stuff is a big thing.
From an industry perspective, so ROS has been around for a long time.
Yeah.
It was a failed robotics company called Willow Garage, and it ended up like spawning a bunch of companies after it died, lived on. But really, in the last, so I work for our robots, so we do this. We've been doing our own ROS testing forever. We've been around for 30 years. There wasn't a ROS 30 years ago, so we've been at our own crap, right? Other companies couldn't do their own stuff, not that crap. But, and so only in the last year or two has ROS big enough, stable enough, widely known enough to actually start enabling us to start using it. You start using it, you can, in a week in Hurricane, pick this up. So it's really like, it's a shame that this didn't exist before, but it's really only been good enough. GitHub and everything about it in the last couple of years. Great.
No, it's definitely the OSRF, the Robotics Foundation. What's the Open Robotics company? So that's maintaining all of this now, and it was really cool. The picture we had from Roscon was actually taken by like the CEO of Robotics. It's awesome. So I'm like, here, can you take this? Yeah, no problem. So it's great. So
he comes to Raleigh.
Yeah.
So this is Python related right now, and it applies more towards the drone. But like, how accurate are like simulations?
So it depends on how much work you put into the simulation. And so basically it's probably mainly focused around the physics engine if you're talking about accuracy in terms of like what it would be versus if I ran it in simulation versus in real world. But it's roughly enough to be able to test your control theory and see whether or not it goes from point A to B roughly in the way that you want it to. But it's not something you can say like tune PID values from or something like that, even if you have like an actual physical model of the drone.
Thank you to Matt and Chris for helping me get this organized, and to NVIDIA, who I don't know or not, but for making everything happen with us. We wouldn't be doing what we're doing without it. I think the plan is to drive a robot around. We're here to answer questions and hang out for a little while before I have to get these guys back to school, figure out what our mechanical team has done in our absence for the lab. And I have more swag to give away. I only have like 2XL and medium shirts because that's what NVIDIA sent. But I'm happy to give them away. I have tons of stickers. Happy to give that away. So,
Pretty good. I'll say, how much pizza is left? So I don't think we need to keep pizzas. If anyone wants the pie, I don't know. Like, oh yeah. So you
Yes.
I know.
So you won this one?
Yeah.
Totally fair draft. Yeah. That they didn't make it anyway.
Yeah, it gives such nice data. You can look at this one, you can look at this one, you can like overlay them. And with this one, we were in a hotel room, of course, because that's how it goes. And you can like see the waves of the curtains from like, and it has
One variant. Yeah. Of course, we can't run it on during actual competitions.
Right. The cost. Yeah, I do FTC, right? I coach an FTC. So yeah, I'm not
Do they?
No.
Yeah.
See, there you go. I don't think we do.
We should allow with FTC.
Yeah. That's a good point. Yeah. Cool. Very cool.
Where modules are and so it's like
the trick is step on the back and pull up.
Yeah.
Step on the back and then pull up. Yeah.
It's great.
This is our secret way of getting help for the chairs. We got to show off the dress.
Yeah. So this is the main we have some limit switches on like the side of it. So if it's on arm, we fix it try to get it to not slam. Yeah.
Not all heroes.
I can unintentionally for the two.
Yeah. So inside robot, we have just set my robot back.
Actually not hot at all. No, and I mean, major hang up for us putting one of these in our robot is it can overheat our systems? And the answer is no.
I know, yeah. I didn't feel like it at all.
No. But underwater, things get really
messed up. Oh, yeah. Absolutely. We'll always host meetup.com.
I don't know if they're ready to go. Is it ready to go? Yeah. Okay. Do we need crowd control? Sure. Okay. We'd love to have this kind of thing. Okay, we're gonna. Are we ready? All right. So. Okay. This is
So do you want to move it?
So that's the first
Okay, so ladies and gentlemen, there's an active robot on the floor. So the wheels are acting independently.
They're both.
I don't know if that works.
That's about it. I don't know
Yeah, so Robotics was actually last year's.
Yeah, normally there's you want
it down? Okay.
By me.
Okay.
All right,
Based
so
on
I've got a
the
controller.
yeah,
So it's not autonomous.
So each of the wheels has a
We're not calling. You guys ready? I don't think they're
always impressed.
The other one would be I have no idea.
I heard 10.
Are you trying to look better?
Yeah, I don't think it's
Yeah, I know the code might not be right. But it's
I think the down was the mechanical class before the stock mission do what you wanted to do. It's not enough overhead.
It's not the controller is too
And the arm is designed out to get the controller.
Well, no. Rewriting.
Pretty fun, yeah. You drive around your curve, you get accelerate and wheels rotate so you can get at the same time. There's a lot of work goes on. You connect a bunch of tests with other things. You had 15 seconds.
Standalone you have to play with.
Yeah, the biggest problem is finding space to run in. This would not be enough to do.
Oh, absolutely.
Some of those things. Yeah, we could actually have it. And it's more fun than the parts.
I didn't know that.
So They're
Just kind of show off our project to the last day of class to someone.
The driver's station itself. And they have to
I know, yeah, I saw the picture of the road.
Yeah.
I saw it last time.
We can use that as
I love using it. That's all we
Well, what do you look like?
We try to teach occasionally speaking life skills.
Yeah, I know, right?
Yeah.
For all of your help. Thank you. Video thank you. So, exciting. Thank you. Oh, wow. Yeah. I'm pushing out. It's not very hot.
Not at all. I'm curious, is it still running?
I don't know.
Use the
keyboard's over here.
Yeah, I want to. Can we flip that one back?
We can switch it over.
Yeah. It's crashed. No, I died. I haven't run successfully, so I guess it's.
Oh, it ended.
It's got fair enough. Oh. The video's only for
yeah.
Maybe? I don't know.
What's your name? Marshall?
Marshall.
Hey, Phil.
Phil, nice to meet you. Very cool.
Yeah, there we go.
In your day job now, do you get to do stuff with robotics?
Not often, though it's interesting. Like, my world sort of slowly collide. Like, every so often I go through this phase where things collide for me. So, for a while I was doing IT administrative work for manufacturing companies, and I got into doing some industrial robotics stuff for it. So, yeah, the good robot. There we go. So, for a while, that was happening, and then it stopped. So, transitioning to consulting work, it's a lot of fun, and that pays the bills. But I've done less of it. The past year, really at the end of the day, it's but I have been crap and I'm like, you don't understand. Ross is the perfect use case because you deploy something for a robot, and I need to guarantee that that environment is other environments are the same as other environments. So if I virtualize it, and I can put all of my different kind of applications across all four nodes and different VMs. Suddenly I can segment and there's all kinds of stuff you can do with computers. It's like all legit PSXI, so vSAN works, the various network stuff. So and if you need more, everybody takes it for granted. It just works.
So do you work out of the?
No, I never. So my team is we'll see. Hey, LiDAR! Woo! So somebody was asking about LiDAR. We've given LiDAR now. That was forwards.
Yeah.
Yeah. This is live LiDAR data from the robot. To read the data from the installed laptop and just
So this one. No, the fact that it's in that footprint, and you can
For most applications, yeah, my favorite thing is
yeah. Oh, right there as you walked up. There, that's me.
Yeah, the pairs of angled legs.
Yeah. It's my convert. Where is the switch box?
The switch box is right. It's right there. So it's rotating.
Almost
So I
like
can
center.
actually see the corners.
Oh, in the center. I see. Yeah.
Yeah. All right. That's the
So
robot,
the
right? The robot's right at that corner.
So,
Something like that.
It's a two-dimensional. The LiDARs are
Well, yeah. At first, I thought this was the edge of the wall.
Yes. Yes. I've seen
Yeah. So we have.
Biggest challenge we had not a bunch you said you were before?
Yeah, so I did setting up the radar there, so we did some stuff around.
Yeah, so that's much
radar data.
Yeah, like well, growing up for like kids running clinics, like what's going on? Yeah, my world was that's really high block to be really so bad. Yeah, eventually our space is that big, but we're always good, appreciate it. Absolutely,
yeah, they love you.
But yeah,
They do great things.
It's actually really hard.
They know what they're doing. So
I will.
this is back on top of that. Exactly. That's really cool.
We always, like I said, try to sneak in some actual life skills in additional context.
I don't think we've met Olivia. Thank you.
Seriously. I was saying, I grew up, I mean, no one else can do that. I couldn't find anyone else.
Like if we have like play programmers and a couple of us are able to do Windows, like you.